Okay, so as I was saying before, what we're going to do today is we're going to build all the way from scratch one of the most classical video games in the history, which is Pong. And I say classic because I believe the first iteration of the game was developed in 1976 or 7, which was even before I was born, which was a long time ago, right? So what's interesting about this game is that in its simplicity, it still has a lot of interesting techniques that we will learn in order to be able to make things such as multiplayer, 2 people playing at the same time, the bouncing ball that we're so familiar with. We're going to have the paddles, which are going to be going up and down, and this is probably one of the things that we will be more interesting about this particular video game is the notion of collision, the notion of 2 objects crashing against each other, and then how to figure that situation when that is happening numerically, and then what to do when that is the case. Okay, and then finally we will just wrap it up by adding scores and adding maybe a splash screen or like a game over screen, things that are like typical things that you implement in video games. Okay, everybody's familiar with Pong, right? It's just I can probably pull a video, but it's basically 2 paddles that move vertically up and down. Okay, and it's this one ball that bounces off the screen. And then the goal of the game is to score the ball in the other player's arena. Okay, very simple, yet very good for educational purposes. Okay, so before we write a single line of code, the first thing that I would like to encourage you guys is that whenever you face a more complex task, such as this one, a video game that has a lot of elements, a lot of interactions. The very first thing we need to do, and this will be a staple on every single computational project that you're going to engage on from here on, before writing a single line of code, the most important thing is that you take a step back, you think about what is it that you're trying to achieve, and then you break down the process of reaching this complex state, the 2 paddles, the ball, bouncing, goals, scoring, etc. Try to break it down into its constituent elements. What is it that I have? What are the elements in my video game? Break them down into single elements, break them down into the rules that relate them, and then build up the game up from scratch, incrementally adding each one of those elements one at a time, and whenever you believe it's pertinent or makes more sense in the scope of your video game. Okay? What I'm saying with this is that it's very, very useful always make ourselves a plan, an action plan. I'm going to start developing this, and then I'm going to add this, and then I'm going to make these 2 things work together. I'm going to add a 3rd thing, and I'm going to wrap it up by making these 2 things work together again, right? That plan may change over the course of your development. It's very likely going to change very often, but at least breaking it down into single unit steps is going to help clearly understand the logic of the video game. It's also going to give you a way to start. But it will also be super helpful as a way of approaching a holistic project. Okay, so that is the very first thing that we're going to do here today, before we write any single line of code. Okay, so if what we want to do is implement Pong which works the way we have described, stepwise, from nothing on, which steps do you think we should pursue to implement this video game? What would you implement first? What would you implement second? What would you implement third? What do you guys think? And here, there's no right or wrong. Here, it's more about your experience, your intuition. Things are going to change while you develop the thing. Don't worry, okay? But your intuition, what does it tell you that you should start building first, for example? Right now, we have nothing. What is the first thing you would do? We would implement the ball. Let's not discuss the details here. We don't care about the technical details here. But to start with, I could start with a black screen, and I could have a ball, right? I could have a circle that bounces off the screen. So I like that. The first thing we're going to implement is the ball. And the ball is going to include several steps, such as, for example, first throwing the ball, then making it bounce, right? And then third, probably making it bounce not in the way that we are used to, which is bouncing off from every wall, but this one this ball has a particular behavior that we haven't really done yet, which is what? When it hits the top and the bottom, it bounces, like we're used to, right? But when it hits the sides, what is it going to do that is special? It goes off the screen, and then it goes back to the center and it starts over again, right? So that will be a new behavior, right? Which we will need to take care of. Okay, so now this is the first thing we implemented. And we're probably going to start here because we've done so many bouncing balls that it's going to be a good warm-up, okay? What is the next thing that you would implement in the game? What is the next element that you think makes sense to implement? Parker, the paddles. That sounds pretty good to me, the paddles. So, what are we going to do with the paddles? We will probably want to roll them to start with. Then we will probably want to move them. So implement some keyboard interaction to make them go up and down, okay? And then the third thing, we will probably have to implement some form of capping the movement of because they cannot move infinitely. They also have to stop at the top or the bottom of the window. It's not exactly bouncing. They're not going to bounce back. They're going to be capped. We're going to constrain their movement, okay? So move and the constraint with its constraints, okay? That sounds good to me as a second step. Great. So we have a bouncing ball and we have two moving paddles on the screen. What else can we do here? What will be your next step? Andrea, what do you think? Oh, we haven't yet. Not in this plan. Okay? And we could have argued, well, if I was a really expert developer, I implement the ball, I implement the paddles, and like the last thing that I could implement about the paddles is making them bounce off the ball, or vice versa, right? But since we haven't really done that yet, I'm going to count it as a special step here, which is going to be collisions, okay? Which is a topic that I will explain in a second. Collisions between the ball and the paddle. We will need to make the ball bounce off not only the top and the side, but also the paddles. Okay? Good. Imagine we have this working already. What do we need to finish our video game? So Lynn. Scoring. I like that. Scoring. Keep track of if the ball goes off one side or the other. Give the right player another point, and then move on and keep going. Okay? Good. How are you guys feeling with this? Do we need more, less? Are we done? I'm going to draw a dashed line here, as in, if we were to think of bare minimums for a video game, this is probably pretty good already. This is PONG and it's working, right? We may want to add some flair. We may want to add like additional features, such as, for example, a game over situation, right? Somewhere where we check, well, if some player has more than 5 goals, then this player won, and then we display like a screen like player 2 won, player 1 won, etc. Right? We may want to perhaps implement a restart situation. Whenever this happens, whenever game over happens, we press a key, R, enter, escape, whatever, and the game starts over again with new scoring, right? And we may want to implement a splash screen. That's also a possibility. But these things, again, are not strictly necessary. We're just going to do them because they feel nice. And they're actually very easy to do. Okay? Okay. So, so let's stick with the plan. Let's start by the beginning, which is usually a good place to start. Let's start by implementing a ball. Can you guys help me? You guys will probably do this already. Can you guys help me create a basic processing sketch that it's, let's say it's fairly large. Let's say somewhere 800 by 600, 1000 by 800, something big on your screen, okay? And start by implementing a class that has it's called ball and has X and Y properties, and it bounces off the screen. Okay? And it gets rendered on the screen. Give it a shot first. I'm going to give you a couple minutes. Okay? If you feel comfortable by implementing this with a class, try. If you don't, try it just on the main code, and then I will explain how to move that into a class. Okay? Good. I think you need to close that bracket. There you go. And do some auto formatting. Exactly. Yeah. Do some auto formatting. Oh, no, 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 no. Careful. What's the problem? No, no, not the semicolon. Semicolon. You need a bracket there. Yes. Exactly. Mm-hmm. Yes, 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 yes. Yeah. And make it show up on the screen. Make it bounce around. Yep. Did you meet the deadline? Your assignment on Wednesday. The other class. Get it? Okay. Okay. So many of you, I've seen many of you have like the bare bones. I'm pretty happy about that. Let me just walk you through how I would do it. Okay. First thing, I'm going to start by creating a processing in active mode. I give it some size, and then because of the style of PONG, what I'm going to do is I'm going to use a black background. I'm going to use white fields for all the geometry, and then I'm going to use no strokes because everything is just going to have the size of whatever it is, right? And if I run this code, obviously I have this just a black screen. Okay. The next thing that I'm going to do, and this is very, very, very important. Okay, I'm going to save my sketch because I don't want to lose progress. And I don't want to implement a lot of code and lose it and then hate my computational professor forever. Okay? So what I'm going to do is I'm going to save this to my desktop, whatever. I'm going to call it PONG. And I'm going to call it PONG version 1. Because it's, as we discussed the other day, it is very helpful to save things incrementally so that we always have previous versions in case we need to go back to them. Okay? So I got PONG 1, which is basically just a black screen. Okay? I'm saving this, and I think there's something. Okay. And now I'm going to save the same thing. I'm going to save version 2, and I'm going to start developing. In version 2, I'm going to add a class with a bouncing ball. Okay? How am I going to do that? I'm going to go here to a new tab, and I'm going to create a new tab that I'm going to call ball, and I'm going to uppercase it. Okay? Because remember, classes are, by convention in processing, class names are uppercase. I'm going to create the structure of a class, give it a name called ball, and the next thing I'm going to do is I'm going to fill in with the properties that a bouncing ball needs, which, as we've done so often, these are going to be X and Y location. These are going to be velocity in the X direction, velocity in the Y direction. And perhaps for this one, I'm going to give it a radius because it will be useful in the future when I start doing collisions. Okay? Good. The next thing that I will do is I'm going to fill in, these are the properties. Or, in technical terms, these are the fields of the class. The next thing that I'm going to add is going to be the constructor, which, if you remember, the constructor is that special function that we use to create new objects, to instantiate objects with values from the template idea, which is the class. Okay? Constructors have a name which is equal to the class, and remember that they have no return type because what they return is actual objects of this type: ball, car, paddle, whatever, right? So the constructor has this special syntax where it's the name of the class, but no return type, okay? So we can open and close parentheses, and we can open and close curly brackets, and this is the bare minimum we need for a constructor. However, remember that one very popular technique that we used was using the constructor to give it parameters, give it information that we then want to store in the particular object that the class is going to return for us. Remember the metaphor of I'm calling the car factory and I'm saying that I want a car, it has to be red, it needs to be has 6 cylinders, whatever, and then the factory takes care of managing that information however they want, and they return back to me a physical car with those properties. Okay? Okay, so what I'm going to do is here in the constructor, I'm going to add all the parameters that I want my constructor to accept. And it's popular to just use either the same that we have for properties or less or more depending on what you do. Okay, so here I'm just going to go for having one argument per property of the class. Okay, so I'm going to say y pause, float velocity in the x direction, float velocity in the y direction, and float the radius. Okay? But now that I'm reading this, as a computational designer, I'm just realizing that for the sake of PONG, because the way this is going to work, because the way the ball is always going to be created is by showing up on the center and having random velocities in the x and y direction, because that's the behavior that this ball in this particular game is going to have, maybe I could choose to save myself a bunch of those, because I know that the ball is always going to start at the center of the screen, and I know that it's always going to have random velocities. Okay? So I could either go for this, or I could either just remove all of those and say, whenever I create a new ball, it's always, always, always going to start from the center of the screen, from the center of the screen, also for y, then velocity in the x direction is going to be some random value between, I'm going to say, -5 and 5, and I will change that very soon, and you guys will see why. And velocity y is going to be some random value also between -5 and 5. And then the radius of this ball, now I'm going to use that for that one, whatever the user or whatever the main program is requiring from me. Okay? Any questions about that? Yes. That is a great question. Very good. Imagine I didn't. And imagine I had the same name. Okay? Remember that variables have this thing called scope, which means that they only have a life that is equal to when they were declared. Okay? And in this block, okay, I have two variables that live here. One, I have the variable that I just created in the constructor, which is going to live only during the duration of the constructor. It's a temporary name that I'm giving to whatever the user is giving me from outside. I'm just calling it R. Okay? It's like a temporal storage. But it just so happens that in this scope, I also have the variables that are on the greater scope before that. This one, this one, this one, this one, this one. Okay? Because they are on a scope that it's one level higher than them. Therefore, here, right now in this scope, I have a conflict of names. I have two things that are called R. I have this one, and I have this one. And because I have two things with the same name, remember that computers cannot deal with that really well, which means that if I write R equals R, processing gets really confused because it doesn't know which R is which. Processing doesn't know that what I mean is that I want to store the value of this R inside of this other R because they look identical. Okay? So there's two ways around that. One is what most people do, which is they just give it different names. So that's why, for example, here I give it radius. Or a very popular technique that you will see very often is just giving it an underscore or an underscore right before. And then here I just write this, and now I don't have a problem. Many people do this underscore, right? Or the other way around that is you can have the same names, okay? But in order to tell processing which R is which, then you can use what's called the this keyword, through which what you're telling processing is that this R, which doesn't have the this, is the one that's coming from the constructor. However, this object, this is referring to the object in which we are right now. Take the R property of this object, so this one, and store whatever the other one, okay? If this looks confusing to you, don't even bother, just give it different names, and you'll be much better off, okay? So that's why, for example, I chose to do radius here and radius here.
So this starts all of them, like all of these objects will start at, like let's say you had an array of these things.
Mm-hmm.
And you set this to like, they all would start in the center and then have random velocity.
Yes, exactly. Anytime you create a ball from wherever, the main program, other class, from an array, whatever, because the only thing you can give it is the radius, they will all start from the center, the exact same name, and they will all get different random velocities.
How would you do it if you wanted to?
Then you will probably want to pass information from outside and tell them where to start. Or, if for whatever reason your game is different, instead of starting from the center, maybe they can start from a random location, from 0 to width and 0 to height. And they can be all scattered on the window, right? Make sense? Good. And then the next basic thing I will want to do is to make this ball show up on the screen. I'm going to do that by creating a render behavior, a render method. And then this render method is going to be just drawing an ellipse in the x and y coordinates of this particular ball, and with 2 times this radius and 2 times this radius. Okay? If I run this code, I have no ball on my screen. Why? Exactly. Because I what? Yeah, R is defined here, and here, and here. What I haven't defined is the actual ball. I have not created. I have the possibility of creating balls now, but I just haven't created anyone in the main program. So what I can do is, here, I can create a ball called B, for example. I can define it in the global scope. And remember that objects, instead of being assigned, they need to be constructed. Okay, so that's why what I'm going to do is that I'm going to say B is going to be equal to a new ball object. And in this case, I cannot just create the ball from a simple constructor, because there's no constructor that only takes no argument. The constructor must take one number. So here, I need to give it a number which will be used as the radius of this ball. Okay? So if I give it, for example, 10 pixels, I got the ball, and now every frame I can render this ball on the screen. Okay? And if I do that, now at the center of the screen, I have ball, which at the moment is rendering, but it's still not moving anywhere. Okay? Why is it not moving? I just haven't implemented the moving behavior yet, right? So let's do that. I'm going to go to the ball, and I'm going to say here, in the behaviors, the things that the ball can do, I'm going to add another one, which is going to be moving. Okay? And what does moving the ball mean? We're very used to this already. What do we do here? Parker. X plus equals vel x, y plus equals vel y. And then I'm going to go back to the main code, and I'm going to say b.render and b.move. I'm going to render and then move the ball every frame. Now the ball is moving, and with a random velocity in each direction, if I start over again, it moves in a random direction again, and that's it. It still doesn't bounce. How can I make it bounce? What is missing here to make the circle bounce? Remember that now we have 2 different behaviors. If we bounce off the top or the bottom of the screen, then what happens? Parker. We change the sign of the velocity in the y direction. So if y is greater than height, or y is less than 0, then we change the value, the sign of the velocity. Velocity y equals minus velocity y. If I run this code, you can see that we bounce, although, oh no, we got a very random, very slow velocity. Okay. However, we have a small problem here. I'm going to make the ball really large, like 100 pixels. And if I look at this right now, how it's bouncing off, what is it bouncing off from? Huh? The center. And do we like that? No. Why not? This is not, it feels like it should bounce off the sides, right? So how can we fix that in our code? We're literally telling that if the center is greater than height or greater than 0, that's when it should bounce. But then, how could we modify this to bounce off the sides of the ball? Parker. If y, and let me draw this, if we have the ball, right, this is the center, what we want to check is this point here, right? So if y, which is this point, plus the radius of the ball, if this point is greater than height, then we bounce off. So if y plus the radius is greater than height, we bounce. What about the other one? Celine. If y minus the radius, because now we're bouncing up, if y minus the radius is 0, then and let's see if this works. Okay? Oh, much better. Okay? Feels much better. Good. We have it bouncing off the top and the bottom. Okay? That's great. But what about the sides? What about the sides? What was the behavior that we wanted to implement on the sides? Claudia. Okay. And do you have an idea of how we could do that? Let's figure out the condition first. If what? Okay. Or x is less than 0. Then what do we do here? X we move the circle to the center, so x width divided by 2, y is equal to height divided by 2, right? Are we good? Let's try this. Don't worry. It's back. Let's try this. Okay, it's kind of doing it, but there's something strange about this. Let me try another run, see if okay. What is wrong here, Matt? What's happening? We are resetting the ball back to the center, but there's something missing because right now what is happening? It's going to the exact same spot over and over again, which doesn't feel. What is it then missing? What do you feel it should be doing instead? Getting some random new directions. Exactly. It isn't. It's going over and over again to the same spot because, yeah, we're moving it back to the center, but velocity x and velocity y stay the same. So it just keeps going with the same velocity x and velocity y. So when we reset the ball back to the center, what else should we do? Apart from just moving it to the center. Brooke. Exactly. I like that. So look at this. We're just going to copy paste the velocity x and blah, blah, blah. Just going to put it here. And then every time it hits one of the sides, we're just going to give it new random velocities. So let's see if this works. Ooh, I like that. Yeah? Okay. How's this looking? Celine? Exactly, it is. Celine proposes that we are even better computational designers and we fix the issue that it's bouncing off the center when the center of the ball hits the sides. This is what we're doing here. So we may want to make it go back to the center when the ball is all the way past the border, right? How do we do that? If we are here and this is the ball and this is x and we're going this way, when do we want, if we want the ball to reset when it's all the way in, which point do we want to check? We want to check this one now? We want to check this one. Whenever this point is all the way here, then that's when we want to reset. Okay? We can do that. So that would be when x minus the radius is greater than width, or when x plus the radius is less than 0. Okay? And if we do that, we can see now, nice, much better. It looks much smoother. Okay? One thing that I would like to argue here is that we don't really need this. If this is working like this, it's perfectly fine. But since we're like very clean and very high-level computational designers, there's something we can notice here, which is these 4 lines of code are pretty much identical to these ones. Which means if we are repeating code, there's probably something we can improve here. Okay? Remember that classes were about encapsulating ideas and concepts inside of properties and behaviors, right? So as a concept, if you were explaining to somebody in your family who doesn't know how to code, if you were explaining them what these 4 lines of code are doing, or these 4 lines of are doing, what would you tell them? Stephanie, sorry. Conceptually. Yes, if you were to explain to somebody who doesn't know how to code what these 4 lines of code are doing, conceptually, to a human, what would you say these are doing? Great. Okay. Okay. We are, yeah, Celine. It's kind of making a new ball. It's somehow resetting the ball, right? It's just whatever it was, it doesn't really matter because we're moving it back to the center and we're giving it new velocities, okay? If that's the case, then perhaps it's starting to make sense to just take these 4 lines of code and encapsulate them into yet a new behavior that we're going to call reset, okay? So check this out. I'm going to add another method here that I'm going to call reset. And I'm going to copy these 4 lines of code here. My ball now has a new thing that it can do, which is just whatever it was, just pop up at the center of the screen again and get new velocities. And now that I've created a little bit of reusable code, what I can do now is I can substitute anywhere that I had these 4 lines of code. I can just substitute it by the behavior of resetting. Okay? How can I do that? I can just remove all these 4 things here and say instead of that, I can just call the reset behavior. Because not only can you, and this is really interesting, not only can the main program or somebody from outside the class call the behaviors of a particular object, the object can call upon its own behaviors as well. The object can decide on its own, oh, I need to reset here, and then just go here, execute this, and then go back to whatever it was. Oh, Matt is not having a great time with this. Well, at least it's not 7 p.m. I don't think so. I think you guys are exaggerating. You see what I did here? These 4 lines of code, I have encapsulated them into a behavior, into a function that I can call anywhere, anytime. And now, whenever this condition meets, for the sake of cleanness, I'm just going to remove all of this. Whenever this condition meets, the object, the ball, this ball, calls its own reset behavior. So it calls reset. It goes here. It executes all of this, and then it goes back here, and it continues whatever it was doing. Okay? It's like your car, when the car detects that it's dark. If you have a modern car, not mine, if you have a modern car where the car detects that it's dark, it turns on the lights automatically because the car can call its own behaviors. You can call them as well. You can turn on the lights. But if the car is smart enough, it can use its own behaviors. Okay? The same would happen here. I can also remove all of this and say, whenever somebody calls the constructor, I'm going to store this value, whatever, but then I'm going to call my own reset function. I'm going to go here, I'm going to set blah, 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 and then go back. And then if I restore this, if I run this code, this circle is bouncing off perfectly fine again. Good? Are we good? Can we move on to the paddles? Any questions? Celine. That works fine, but then you would have to manage the object from a level hierarchy, and there will be people who would consider that not to be so clean. Okay, if you encapsulate all the behavior inside of the ball itself, then you're probably much better off because the ball knows how to deal with its own stuff. Also, you're not creating a new object, you're not allocating new memory, you're not going to the heap. So for one object, it's not a problem. But if you had a million of those and you would have to create them again, okay? Okay, so I'm going to save this as PONG version 2, right? And now that I've got it, I'm going to save a new version called 3, and I'm going to start working on that, okay? You determine it when you create the ball. In the main code, remember, you pass it a number, 20, and then that gets taken by the constructor, and then it gets stored as the R property of the ball. It's semi-arbitrary. There's a point where we're starting to make decisions just by design, right? Because in this particular class, for example, the we know that this ball has this behavior. It shows up from the center, has random velocities, but the radius is probably something that we want to control because maybe if we make the game larger, then we want a larger ball. If we were to make this game programmatic, we would want to create the ball with a size that is a fraction of the screen, right? And that is a bit harder to do from inside the ball. So it's better from us, from a level above. We are better off calling the factory and being like, I know the size of my window, so give me a ball that's like a 20th of that size. It would be, perhaps, if you want to be like super, super clean, you're right. We would probably want to have velocities that are also a proportion of how large the screen is. That's a good point. Mm-hmm.
Can you do like this is includes like 0 on the velocities? Can you make it so it's like random -5 to -3 and then random 3 to 5?
That is a really good question, and I was going to go over that in later. Because as Brooke is pointing out, if we do -5 and -5, this is okay, but if we start drawing, you see, it may happen that certain things like this happen. It may so happen that when we roll the dice for these two velocities, we may get values that are both very close to 0. And that is not a great gameplay experience because these two guys are going to have like the slowest ball ever, and they're going to be like, this sucks. So we will, and that's something we can do later, we will want to play around a little with these values and create balls that shoot out to the sides much faster than they shoot out up and down to make the game more fun, and then leverage somehow that the ball either goes to this side or this side. But that's going to be in the stretch goals. Okay, we will talk about that later. We're going to keep this random for the time. Okay, but that's a really good question. Okay, I'm gonna close the video to say that. Okay. Okay. So let's move on to the paddles. Okay. Um. Okay. Great. So the next thing we want to do is we want to create two. We're going to create two paddles on the sides of the window, right? And we're going to do that obviously as well with classes. Okay. So I'm going to. Okay. I'm going to clean this a little bit. Okay. And imagine we have the window and we have the paddle. Okay. Let's design a little bit and then we start implementing the class. What properties do you think will be important for my paddle before I start coding anything? Okay. What will I want to code? Which properties, like for the ball, they were x and y, velocities, radius. What do you think we will need for a paddle? What will be important here? Parker. Position. Measured like what? X and Y? Okay. So just Y. Okay. I'm gonna object to that. I think having X will also be helpful for the reasons that I will explain in a second. Okay. So we're gonna have X and Y of the rectangle. Okay. Question. For the ball, it was the center because it felt obvious. But now for the rectangle, are we gonna want the X and Y of the center or the X and Y of the top left corner, which is what we usually use for rectangles? What do you guys think? The center? Why? Mm-hmm. Okay, I like that. That makes a lot of sense. We could do the center because since we're going to have them in two sides, it's going to perhaps make it easier or more symmetrical to measure distances to the sides. That's a very good point. Okay. Any other thoughts about that? Okay. As many things at this level, there is no right or wrong questions anymore. It's just a matter of design and options and preference and personal choices. Okay. That Brooks point is very good, but what I'm going to suggest instead is that we use the top left corner. Okay, because even though for positioning it may make our lives a bit harder, but I know, and I know that because of my experience, that when we start doing collisions, it's actually going to make our lives much more easy. Okay, so this one I'm going to ask you to trust me. We're going to choose the top left corner, even though at the beginning for positioning it's going to make our life a bit harder. Okay, but when we reach collisions, it will make it so much easier. Okay, so this is going to be the X and Y of the top left corner. What else is important in our paddles? Width, I like that, and probably height as well, right? So width and height. What else will you add as a property of the paddle? Do you need anything? Celine, velocity, why? Interesting. Why would you add that? Okay, I like that. She argues, well, the paddles are going to be moving up and down. So at least perhaps it feels like we would need a velocity y. Okay, that is a good point. I instead, I would argue that since the paddle is not going to be moving on its own, but it's going to be moving with the keys, then perhaps it's more convenient to just tell it from the outside how much it should move up or down. Okay, so we could add velocity y, but I think in this particular case, we don't really need it too much. And I will show a technique on why that is the case. Okay. Okay. So let's start with this and see if we need anything else. We'll just add it on the fly. Okay. So I'm gonna create a new tab. I'm gonna call it paddle, and then I'm gonna create a class called paddle that has what? It has X and Y location, and it has a width and a height. Then the constructor, because in this case, nothing is going to be generated randomly. Okay, I will want to have the X and Y location and the X and the width and the height. Okay, so I can say, well, this is going to take X position, this is going to take Y position, this is going to take the width, and this is going to take the height. And see, please notice here how I am not using the word width, because I don't want processing to get confused with the width of the window, right? So I'm just using width, or I could use uppercase W, I could use lowercase w and an underscore, up to you, okay? And then I can say whatever the user gives me from outside, X, I'm going to store it in X. Whatever is being given me as Y pos, I'm going to store it at Y. W is going to be width, and H is going to be height. Okay. And as with many other things, to Brooke's point before, we could also say, well, if I know that the starting point of the paddles is always going to be the middle of the screen, vertically, then maybe I don't need Y. Maybe I can just say, I can just take this away and say, well, Y should always be height divided by 2. Okay? Yes? No? Questions? Again, this is your choice. It's up to you. Okay? Maybe in your game, the paddles don't start from the center, and you wanna do it a different way. It's up to you. Okay. So I am going to also add a render method, which is going to draw a a rectangle at X and Y with width and with height. Okay. Okay. And if I do that, then I can go back to the main code, and then I can add my 2 paddles, right? However, first question here. Now it's not just one ball that I will add. It's going to be 2 paddles, okay? Which is multiple objects, multiple copies of the same thing, right? If that is the case, we usually store them as arrays. However, for the sake of just having 2 paddles, what would you guys go for? Would you go for having an array of 2 paddles, or would you just go for having 2 different paddle objects, like paddle left, paddle right? 2 different ones. Why? It's easier. It's easier to implement. It is. Maybe, but you actually can. If you say paddles 0, you might be moving the left one, and if you say paddles 1, square bracket 1, maybe you're moving the right one. Okay? But I agree. For the sake of just having 2 objects, not having like 15 or 20, and because we know that it's always going to be 2 and they're never going to grow or shrink, then perhaps an array in this scenario is a little bit of an overkill. So it's probably easier to just maintain left paddle and right paddle as 2 independent objects. Okay? So we're going to go for that approach. I'm going to create a paddle object called left paddle. I'm going to create another paddle object called right paddle. And here in setup, I'm going to initialize them both, left paddle. And this is going to be a new paddle object where I'm going to give it X and Y locations. Okay? So I'm going to give it, for example, 100 pixels inside X. I'm going to put it at the center, so height divided by 2. I'm going to give it 50, sorry, not 50, 20 pixels width and 100 pixels height. And for the right paddle, I'm going to do something very similar. But what I'm going to do is I'm going to say the paddle is going to be at width minus 100 so that we have the same margin on both sides. Then vertically it's going to be at the center and then the same size as the previous paddle. Okay. And again, to the point that Brooke made before, perhaps in the future we may want to make this a bit more programmatic, like have the size of the paddles be some kind of factor of the size of the window to adapt better to larger or smaller windows. But for the time being, we're going to keep it a bit simpler, and then we can improve it later. Okay. But this is another object. Right paddle doesn't know that you created an object called left paddle with the same height. Oh, sorry, I changed it. I move it back to this. You're right. I move it back to this. But if I hadn't, yes, exactly. Okay. Good. And now that I have my both paddles, I can just say left paddle dot render and right paddle dot render. And if I render these two paddles, this is what I get. Yes. Okay. This is what I'm getting. And here now, I am running into the problem that Brooke was trying to solve before. I created, because I kept X and Y as the top left corner, then it just so happens that X and Y is this point, and this thing, even though Y is height half, it doesn't look vertically aligned because this point is at the center of the screen. But I want the whole thing to look like it's at the center of the screen. So what coordinates should I then use for this paddle and for that one? What I would need to do is Y 50 pixels less. Exactly. To the height, I need to subtract 50 pixels, which is the height of the paddle divided by 2. And to the width, to where it is in the x direction, I need to subtract half the width, which is 10 pixels. Okay? So if I do that, if I say 100 minus 10, and height divided by 2 minus 50. And then for width, it's going to be minus 100 minus 10. And for height is height minus 50. Then things are now perfectly aligned, and the two margins here are exactly the same. Okay? And obviously, you can start seeing how there's a lot of hard coding here that is not very clean, it's not definitely programmatic. So we could probably start creating global variables that define the size of the paddles and then use them here as like the size, the width of the paddle divided by 2, blah, 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 and make things a bit more programmatic, okay? But I'm going to leave that as an exercise for you guys, okay? Because when we do complex things, sometimes hard coding things to start with makes it easier to understand, okay? Okay, good. We have two paddles and they're showing up on the screen. Great. What is the next thing we need to do? According to the plan that I just erased from the backboard, from the whiteboard, we first had to draw the paddles. What was the next thing to do with them? To move them, okay? Okay, so that is actually going to be pretty easy. Here, in draw, I can implement some key press functions, some key press variables, and we can say if key press is true, then let's look at which keys are being pressed right now, okay? And move the left or the right paddle up or down. So for example, I'm gonna choose for the right paddle, I'm gonna choose the up and down arrows. So here I can say if key pressed equals true, and then I can start figuring out if the up or down arrows have been pressed. So for example, here I can say if key equals coded and key code equals up, then I should move the right paddle a little bit up. Otherwise, if key is coded and key code is down, then I should move the right paddle down. Okay? But how do I move the right paddle up or down? Parker. I add to the X, to the Y location. Okay? So I could add to the Y location. Let me do that. I'm going to do right paddle dot, and then I can, since I'm using the dot notation, I can access all the properties, H, Y, X, and Y, and all the functions, all the methods, right? So I can access the Y property of the right paddle and say minus equals 1 pixel, for example. And if I want to go down, I can say right paddle dot Y plus equals another pixel. And to Celine's point before, this is a little bit of hard coding. Perhaps I want to have a global variable called vertical velocity for paddles, or I want to have that embedded inside of the class. It's up to me as a designer, okay? But let's start hard coding it a little bit. If I do this, I can run this code, I can click, and then you can see how I press up and down, and the right paddle goes up and it goes down, okay? Right now it's a little bit too slow, so I'm gonna crank this up. I'm gonna do 5 pixels. I'm gonna move this, and then it goes up, and it goes down. Okay, looking much better. You may want, as a way of making the game harder or easier, maybe the paddle moves faster or slower. Maybe up to you as a designer. Okay. So we got the right one working, and we will soon get to the left one. But we have something that is not working yet. This thing, it's going up, out of bounds, right? The paddle is not correctly capped on the top and the bottom of the top and the bottom of the window. Okay. So how can we prevent that from happening? If y is less than 0, where do we write that? Mia suggests checking the y if it's less than 0. Where can we add that? Claudia? Oh, you need more coffee. Celine, where will you do that? If here, which is where I am changing the y location, if this is where I'm changing the y location, then perhaps here is what I should do all those checks to impede the thing from going away. Okay, so I say, for example, if right paddle dot y is less than 0, then what can I do to stop it? If I went too far up, how do I stop it? Bruce. Oh, yeah, exactly. I can say the y property of the right paddle, if it went too far up, I don't care what it was. I just want to keep it at 0. Okay? So if it went too far up, just stick it at 0. And similarly, Okay, so let's see if this works. I'm gonna go up and, oh, nice, stops there. Okay. What about going down? Can somebody help me fix this when it's going down? Matt, you're in. Come on. If right paddle dot y is greater than height, greater than height, then right paddle dot y is equal to the height. If the y of the paddle went too far up, then we just keep it at height. Okay? Let me run this code. The thing is working for up, but as I go down, let's see what happens. Take a look at what's happening. It's gonna go, but I'm still pressing, so it should be going all the way down, but no, it just shows up there again. It's almost there, but it's not quite. Why? Why is it going through a little bit? Mia, why is it going through? Exactly. Because what I'm stopping from going into here is the top left corner, is Y. I'm checking and I'm stopping the paddle once this point here, the top left corner, hits the bottom. So how can I stop it when this part here is the one that, yeah. Exactly. If what I check is instead of this point, I check this point here, but I can say whenever y plus the height is greater than this, then keep y equal to that. So I can say if whenever y plus right paddle dot height is greater than height, then just stick it. Make this point equal to the height of the window minus the height of the paddle. Okay? Height of the window minus right paddle dot height. Okay, I'm gonna go up, this works. I'm gonna go down, and this works. Okay? So everything is working. Great. Matt, are you with us? Did I kill you already? It's gonna get a time. Okay. Any questions about what we've done? We just need. That's why we're having this class. Okay? Because as I told you 2 weeks ago, beyond classes and object, we're gonna learn nothing new. But what we're gonna learn is many different ways of looking at the same topic from different angles. Okay? So, Celine, do you see something wrong or not wrong? This is working. But do you see something that's improvable here? It's bothering me a lot. Why? What is it bothering you about this? Can you elaborate? We're repeating code. That's usually not a great thing. We're repeating a lot of code here. Okay, and if we were like purist, orthodox computer scientists, or we were hanging out with those kind of people, which I don't know how you would do that. But anyway, if we would hang out with those kind of people, they would tell you like, this is so not cool because from the outside, from the main program, you are directly manipulating and managing internal information from the paddle. Okay? which it's fine, it works, it does the trick, but it's usually not considered a great practice. Because what's considered good practice is what's called encapsulation. And by encapsulation, I mean everything that has to do with the behavior of the paddle and the paddle checking itself what it is and whether if it should go back and forth, whatever. All of that code should be as much as possible packed inside of the paddle class itself. And I should not be the one having to manage if this is over the top or not, whatever. That's like asking me, like, hey, you have a car, so you're driving the car, but you should also pay attention to whether if all the screws are in place and like if you're pressing the pedal, whether if the gas is flowing correctly into the engine. The car should be able to figure that out automatically. That's what you're paying for, right? This is kind of a similar situation. If I were to, this is fine, but if I were to implement also the left paddle, I would need to basically copy paste this chunk and change right paddle, Y, whatever, and perform all the checking again. Okay? Which it works again, but since it's my duty to teach you high level orders, then we can make this a bit cleaner. And we can make this a bit cleaner by packing everything that relates to the paddle moving vertically, packing everything inside of the paddle. Okay? Because this, again, is something that feels like the paddle is moving. So if it is, then why not just create a move behavior to the paddle and then just call that move behavior from the paddle whenever we press the key and let the paddle figure out whether if it should stop or not, blah, blah, blah. Okay? Does that make sense? Again, this is just a choice that we're doing here for the sake of good design. But since that works, that could go through. It's fine. Okay? So let's go for that. We're going to go back to the paddle and we're going to say, I'm going to implement a function that is going to be called move. And anytime somebody calls the move function of any paddle, the right one or the left one, here I'm going to take care of moving the Y paddle up or down, okay, and fixing it to the top or the bottom. So for example, here the conditions, I'm going to say if Y is less than 0, then Y should be equal to 0. Otherwise, else if Y plus the height of this paddle is greater than the height of the window, then Y should be equal to the height of the window minus the height of this paddle, which is literally, it's just the exact same thing we wrote here, but look how much shorter. I'm going to copy this. Look how much shorter and how much more elegant it is to write this than to write all this chunk of stuff here. What we had in the main code, right? You don't have to do right paddle because this behavior is for any paddle. It's the behavior that's contained inside of any paddle. Right? So now I can substitute all this ugly and bothering piece of code to Celine's words, and I can just say here, I can say right paddle move, and here, and I can say right paddle move. Okay? Okay, great. Although anybody sees a problem with what we're doing here? There's so many problems, right? First problem. The paddle has a behavior called move. But how do we know if we're telling the paddle to move up or down? Should we create perhaps two behaviors, move up and move down, and then have them independently? That could work. But here, we're going to make something a bit cleaner. Okay? What we're going to do is we're going to we're going to rename this movement and we're going to rename it move vertically, for example. And then what we're going to do is we're going to make this behavior accept information. How much do you want to move vertically? So that I can tell the paddle, move -1, move +2, move -3, and then the paddle will know exactly where to move accordingly. Okay? So in the move vertically behavior, I'm going to add a parameter called, I'm going to name it amount, or you could name it speed, or you could name it quantity. It's up to you. Or difference in the y direction, or increment in the y direction. Up to you, okay? And then inside of this, and I'm going to delete this ugly stuff, inside of here, I can say, now that I know how much I need to move vertically, because whoever calls this method is telling me, then I'm going to increase the value of y by the increment in y, by whatever I've been told to. And if I do that, now I can go back to my main code and rewrite this move vertically and give it some values. So if I'm moving up, before I had -5, right? So here I type -5, and now I have +5. And my paddle now moves up and down and stops. And to Celine's point, this how much easier is it to read this line of code as a concept, as a human. Right paddle dot move vertically parenthesis -5, and this other one, right paddle move vertically +5. Whatever happens inside of move vertically, it's the paddle's problem. The paddle should figure it out. And actually, the paddle is being really good at it, because whenever it moves vertically, it changes its position, and then it performs a couple checks. And if it goes too far in any direction, then it just constrains the movement, right? And now that I have this function available for all the paddles, now implementing the left paddle is just going to be a piece of cake. Okay, Parker. Okay, I can take a look at that in a second. Okay, let me implement the left one. Well, actually, can you guys try implementing the left one? I mean, it should be super straightforward now. Give it spend a couple minutes, spend a minute or 30 seconds. You don't need more than 30 seconds, and implement the left paddle moving up and down. Okay. Can you go back to your code? Okay, so let me. Yes. This else if you see it's outside of key press.
Oh, do I have an extra bracket?
Yes. And that's why indentation is amazing to keep track of those things. Indent, auto indent. There you go. You see? Yeah. Mm-hmm. Because height is checked here at runtime. Mm-hmm. You create it after, and you create it here, just for the sake of these two values already having the size. But whenever you're calling this, height is already at runtime. It has the and if you were changing the window, those changes will reflect in those ones as well. Okay, piece of cake. I can add more here and say else if, and then I can choose whichever keys I want. So for example, I'm going to choose T, and And remember that it's good practice to do the lowercase and the uppercase check. And here I can say left paddle dot move vertically. Move vertically -5. And otherwise, if key equals G of lowercase g, or key equals uppercase G, then left paddle dot move vertically 5 pixels. And this thing goes up, this thing goes, and this, I got the two ones. Okay. Sorry to say that again. Yes. Then can you indent everything again and make sure that all the key checks are inside key press? They are? Okay. Coming to the rescue.
Now it's doing. I didn't change anything. Why is it? I literally didn't change anything. I just auto indented and then
Maybe your system is triggering. You know when you press a key and you get like all these like letters. Maybe your system is like triggering that, and that's what's affecting. I don't know. I've had weird experiences with key pressing and Macs. Well, questions? Parker. It froze. It's a good question. With this setup, you cannot be pressing two keys at the same time because see what happens. Since I have an if else, if key is blah blah blah, if I'm pressing up for both players, this triggers first. Therefore, I move the right paddle, and then the left one doesn't trigger. Okay? So you could say, well, then it's very easy. I just do independent ifs that are not connected with else's, and because they're independent situations, they will trigger all. But that will not help as well either. Because the problem is, if you remember the day we talked about keys, I said very carefully that key, the variable key contains the value of the last key that was ever pressed by the user. Which means, and think about this, which means if I'm pressing up, the right player is pressing up, key equals key code is up, okay? But even if I'm still pressing up the up key, if the other player presses T to go up, then the value of key is not anymore coded nor key code up. The value of key turns into T, even though they're both pressed at the same time. Which means that when I want to do multiple key recognitions at the same time, I will have to use a different technique, okay? Which I will explain by the end of today, okay? But this is going to work for the time being, okay? For Mac users, try to use letters, because I think the Mac OS has this thing where when you press a letter continuously, then it gives you like a pop-up with like the different options for like A with tildes, A with umlauts, blah, blah, blah. I think that conflicts with processing. So you must choose keys that do not have alternative versions. Like for example, X, I don't even know which ones there are, like H. I don't think there's like versions of H.
None of the letters.
Huh?
None of the letters have anything else beside.
No, the vowels, for example, they all have alternative.
Oh, you're saying like
Yeah. So
option E or
you have to choose letters that have no alternative spellings, like H, W, X. I'm assuming. I don't remember. I don't really know. I'm not a Mac user. Okay. Okay. I'm gonna save this as PONG number 3, and I'm going to also save this a new version PONG number 4 before I start adding more stuff. Okay. And I'm gonna stop the video just to make sure that. Okay. Any questions before we move on? Are you guys excited? We're almost there. We're very close. Matt is having a tough day today. Okay, what is the next thing in the roadmap to implement? Collisions, okay? And before we do that, I'm going to take a quick break and make some remarks about collisions, okay? What does collision mean? Collision means that what you're trying to do is you're trying to check whether if two particular geometries are so close to each other that they have some overlap in between them, okay? That for us humans is very intuitive to understand, but for computers, it's not so much. Because like, how would you tell processing that, how would you ask processing whether if this circle is on top of this rectangle, or if they have any area that overlaps? Would you draw them? And then you would go pixel by pixel, checking if like the colors are darker in the center or something. That's incredibly costly, is very imprecise, doesn't work, okay? So the idea of collisions is actually it's a really deep topic, and there's a lot of people figuring out in their PhD dissertations how to do this computationally in a fast, optimized way, and the success of many video game platforms, for example, such as Unity, Unreal, etc., is that they come with a lot of tools that help you figure out this problem without having to get into the nitty-gritties. Okay. However, in processing, we don't have those techniques. But also, the good news is that we're not programming Call of Duty. We don't have to compute the collision of a tank against a house, right? Which is a very complex task. However, we just have to compute the collision of a circle with a rectangle, which, if we know where the circle is and the dimensions of the circle, and if we know what the rectangle is and the dimensions of the rectangle, it's actually a not so hard task. It's pretty simple, okay? And let me give you an example of that. If we go even simpler and we say, instead of these two, let me compute whether if this circle is colliding with this other circle, okay? Right now they're not, right? It's fine. But what is the information that I know computationally in processing? If I had two balls, what information would I know about each one? I would know the coordinates x, y of the center. I would know the radius. And for the other one, I would have the x and y of the center, and I would have the radius, right? This is x and x, y1, radius 1, x2, y2, radius 2. Right now, they're not colliding. If this guy is moving closer, they're not colliding, not colliding, not colliding, all the way until now, at which point they are colliding. But if the only thing that I know is the 6 numbers, x, y, radius, x, y, and radius of these two balls, how could I numerically, with those numbers, figure out if these two elements are overlapping with each other? For circles, it's really easy. What do you guys think? Equals what? It's even simpler than that. If I know the center of these two circles, I know the distance between the two circles, right? I can do it with trigonometry, or I can use processing's distance, right? And if I know that distance, how can I use that distance to figure out if the two circles are on top of each other or not? distance is less than the addition of this radius plus the other radius, then they are colliding. Otherwise, they're not. It's just simple. This is the rule. If the distance between this x and y is less than the sum of the two radii, then, which is the case here. This is one radius, and if this distance is less than this radius plus this radius, they are overlapping. Whoa! Numbers are your friends. Okay? Okay. So, similarly, for a circle and a rectangle, it's not so straightforward, but it's also pretty easy as well to do. Okay? Let's start with a simpler scenario. Let's imagine that we have a really large rectangle and a really small circle. So small that we're not even going to care about the radius. We're going to just create collision by imagining whether if the center of this ball is inside of the rectangle. Okay? And we will expand that later to account for the actual size of the thing. Okay? If that's the case, then how can we figure out if the center of the circle is inside of this rectangle? When I told you the other day, when sometimes we have complex rules, it's kind of like not easy to understand how to like width and height, blah, blah, blah. A good technique to break down these logics is to start off with a very simple example with numbers and try it out with actual concrete numbers, and then abstract and then extrapolate that to variables. Okay? So let's try that. If I say I have a rectangle and my rectangle is at 150 and my rectangle is 20 pixels width and is 100 pixels in height. Okay? Oh, that's me. Imagine we have that rectangle, okay? And I ask you, is the point the center of the ball? Would a point at coordinates 110 and 75, is this point inside of the rectangle or not? Who says yes? Matt, you say yes. Who says yes? Who says no? Oh my God, you guys need coffee. This point is at the center because x is greater than 100 and is less than 120, right? And y is greater than 50 and is less than, what is it, 150, right? What about the point in coordinates 125, 25? No. What about the point in coordinates 175, 119? No? Oh yeah, no. Actually, it isn't. You're right. Okay. What about 115 and 119? What about this one? This is inside, okay? What about 120 and 150? How about this one? This is exactly this corner here, okay? That, I'm going to leave it up to you to decide because technically it's exactly at the border. Whether if that is inside or not for you, it's just halfway in between, so you can decide in your video game whether if that counts as inside or not, okay? And now you can very clearly understand which of these points is inside or not. Because inside of your brain, you're doing some numerical operations. What numerical operations are you doing? Why is this point inside of the rectangle? Because the x-coordinate is greater than 100, and the x-coordinate is less than 100 plus the width, 120. So because 110 is between 100 and 120, and ampersand, 75 is greater than 50, but it's also less than 150. Right? You see this? That is the numerical rule that you have done in your brains to figure out if that is inside of this rectangle. If the point has collided with the rectangle. So, if instead of numbers, we extrapolate that rule with variables, we could write something like, if the x-coordinate of the point is greater than the x-coordinate of the rectangle, because we're doing this point here, remember? And if the x-coordinate of the point is less than the x-coordinate of the rectangle plus the width of the rectangle, and if the y-coordinate of the point is greater than the y-point of the rectangle, and if the y-coordinate of the point is less than the rectangle plus the height of the rectangle, if all of these four things are true, then the point is inside of the rectangle. Hence, the point has collided, has hit the rectangle. Pun intended. Okay? Any questions? Well, if that's the case, then for starters, let's implement the ball bouncing off from the center. We will account for the radius in a second, okay? But let's start simpler. Let's start to figure out if we can detect if the ball is hitting the rectangle from the center, okay? Let's go for it. Okay. So here, we're going to go to the main code, because here we have access to, for example, the right paddle. We have access also to the ball, and we can compute numbers all together. Okay. So here, what I'm going to do is I'm going to implement that rule there. I'm going to check if at any point the x-coordinate of the ball is greater than the rectangle, and blah, blah, blah. And then if that is true, then I will do something. Okay? What is it that I'm going to do? I'm going to say, well, if the x-coordinate of the ball is greater than, for example, right paddle dot x, double ampersand. If the x-coordinate of the ball is less than the x-coordinate of the right paddle plus the width of the right paddle, okay? And I need another condition. If the y of the paddle of the ball is greater than the y of the paddle, and if the y of the ball is less than right paddle y plus right paddle dot height, if all of this is true, then I have hit the right paddle. Okay? In order to see if that is true and if it works, I'm going to print a message in the console every time that happens. Okay? So I'm going to say print line right paddle hit. And some frame count to see when that happens multiple times. Okay? Let me execute this code. Okay? And let me move up and down. So, of course, it's going to start shooting to the left, right? Okay, look at this, look at this. Is this true? Is this true? Yes. While the ball was moving to the right, it hit the paddle many frames, during many frames. And it's going to happen again sometime as soon as the ball goes to the right. Okay? Okay, cool. Any questions about this? Okay, we are printing a message, but that's not what we want. We want is for the ball to bounce off the paddle, right? So what do we need to do? Here, when this is true, we can print a message, but what else do we need to do? How do we make the ball bounce back? We know this one. Exactly. We invert, we flip the velocity x of the ball. So here we can say b dot velocity x is going to be equal to negative b dot velocity x. And if I run this code, and look at this, look at this, look at this. Oh my God. It's going to happen again. It's going to happen again. Look, 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 look. Oi. Right? Bruce is back. Yes. Okay? So collisions sound like a really daunting thing, but they're actually just as easy as breaking down the numerical rules that relate the geometry. And because we're working with very simple geometry, it just so happens that the rules behind collisions are going to be super easy as well. Okay? Okay, let's take a couple minute break. It's been a lot. Okay, let's take a couple minutes and then we come back and we implement the left paddle, we implement the radius, and once we have that, we're pretty much done. Okay, so it's just about polishing and things. I'm not sure. I'm gonna say this again. I've said it before, but I'm not sure if you realize that you've been coding in your life for 4 weeks.
That's like the whole.
And
idea.
you are.
That's the whole idea.
And you are like at a very high level of things here.
But I'm not.
But you will. But you will be there because think about it. The only thing you've been doing so far is being given technical instructions, but you haven't really put it to practice so much.
That's the only way that I ever get slightly like any success.
What?
Is like with the workouts and stuff like that.
Exactly. So that's what we're doing here. I'm building examples with you so that we all learn the nitty gritties and tricks and how to improve things. You can always go back to writing like long and tedious code if you want. If you understand it better, and if it does the job for you, better. My task here is to teach you higher level stuff so that if you ever want to go back to low level, it's totally up to you. Okay? Also, you haven't realized that you are going to be working on your final project for 6 more weeks. So you're going to have a lot of time to practice. And you're going to have a lot of time to, like, at your own pace, and as much as you can, introduce new features, new stuff. That's going to be totally at your own rhythm from here on, okay? But this is pretty high-level stuff. It's very natural that you're a little bit overwhelmed, okay?
It's overwhelmed with that thing.
Also, do you realize that if you are overwhelmed, it's probably because you're learning a lot of stuff? If the class, if you were...
I spend hours and I don't get anywhere.
Do you think you don't get anywhere? Do you think you're at the same position as you were on week 0?
Obviously not, but I still don't feel like I understand things that we learned like 3 weeks ago.
Have you practiced them? Not that much, right? I've had a lot of students like that. Trust me, it's going to get much better. You just need to practice. Parker. And on top of that, Jonathan and I have your back. So you can post questions. We have office hours. Well, if you don't have time in your life for this, that is something I'm not sure I can help much with, because that's a time management issue. But if you, Parker.
So I implemented both sides of collision, but I'm getting a bug with it that I can't really figure out why.
Let me move on with this. Let me rewrite this in a way that makes better sense, and maybe that helps you. And if it doesn't, I'll take a look. Okay. Okay. So let's continue. So this is great, but it's a little coarse, a little constrained, because it's only bouncing for the right paddle, and it's only bouncing from the center. And of course, Celine is horrified by this, because it's so much code. It's like, so there's probably a better way to do this, okay? Which we're gonna see right now, okay? The first thing is that this is great, but it's not very programmatic, because if we wanted to do this check for the left paddle, we would have to copy paste this and replace any of this. And if we had 7 different paddles for some reason, we would have to copy paste the whole thing. Parker, we would have to copy paste the whole thing. So it's not programmatic. We need to figure out a way to make this part of the behavior of the paddle or part of the behavior of the ball. Because there is a behavior that is the paddle and the ball both colliding, and then the ball changing, steering back based off from that. Okay? So at this point now, what we need to do is we need to implement a new behavior either on the paddle or either in the ball, and then that behavior is going to encapsulate things bouncing, making that check, and if the check is true, then bouncing the ball back out. Okay? How are we going to do this? And this is probably going to be like the aha moment, right? What we're going to do is we have 2 classes. We have the ball and the paddle. And we have paddle objects and we have ball objects, right? So now what we need to do is we need to figure out a way to make them talk to each other like we've done here. Here, we could relate the values of one and the other because we are at a higher level. We are in the main program, so we can see the ball, we can see the paddle. But what we need to do is we need to figure out a way to make the paddle see the ball, or to make the ball see the paddle, and then do whatever they have to do on their own. Okay? How are we going to do that? We're going to do it by implementing in either the paddle or the ball. I think I'm going to go for the paddle. Okay? But it's just a choice. You could have chosen otherwise. I'm going to go for the paddle, and I'm going to implement in the paddle, I'm going to implement a behavior where the paddle is going to, I'm going to give the paddle the ball, and I'm going to tell the paddle, hey, check out if you are colliding with this thing. And if you are, change the direction of that thing. The way I'm going to do that is the way I do with implementing any kind of behavior. First, I'm going to go to the paddle, and I'm going to create a new behavior, and I'm going to call, for example, check collision. And I'm going to copy and paste this inside here for the sake of reference. And remember that what I did was, in order to check the collision, I would check if the ball is greater than the x of the paddle, the height of the paddle, blah, blah, blah. Now all of that is going to be much easier to write, because since I'm inside of the paddle, I can save myself all the right paddle, whatever, and just go directly to the x and y and width and height properties of this guy. Okay? So here I will be able to write a check in the form of if the x property of the paddle is greater than x, or if the x property of the ball is less than x plus width, etc., etc. Okay? However, the problem is that I am inside of the paddle. Bless you. I'm inside of the paddle. And the paddle is its own thing. The paddle is like paddle doesn't even know where it is. It doesn't know that it's in a game, whatever. The paddle just has X and Y properties and moves around, right? How can I, from within the paddle, how can I figure out if the paddle is hitting with a ball object? Well, and this is what I really, really want you guys to pay attention. What I can do is, what I can say is, well, just as any other method can work with information that is coming from the outside, right? I can do the exact same thing for this method, and I can give it information to this paddle to check if it's bouncing with the ball. What is the best possible information that I can give the paddle to check if it's hitting a ball? Well, it turns out that the best possible information is an actual ball object, which means that the arguments that this function is going to take a ball. Okay? So here in the arguments, I can write, in order to check a collision, I need someone to give the paddle a ball object that I'm going to call B. But remember, this is processing. All the variables have to be strongly typed. So, is B a float? Is it an integer? Is it a string? Is it a Boolean? What is it? Bruce? It's an object of the type ball. It's a variable of the type ball. What? It turns out that not only can I exchange doubles, integers, bows, whatever, I can also exchange types that I have custom created. I can give the paddle an object of a type ball, and here I can say if b.x, I'm going to call this ball, okay? If the x of the ball is greater than the x of this paddle, and the x of the ball is less than the x of this paddle plus the width, and the y of the paddle is greater than this y, and the y of the paddle is less than y plus height. If all of those criteria meet, it means that this ball has hit this paddle. This ball that has been given to this paddle is hitting this paddle. So for example, I'm going to print this message. Print line hitting a paddle. And just the frame count for the sake of, okay, and I'm going to kill all this stuff here. But this is not working because I'm still here. I'm not checking anything. So in the main code, now what I need to do is anytime I want to check that collision, I need to say, for example, write paddle dot check collision with the ball object, which is called B in the main program. And if I run this code, let's see if that is true. I'm only checking it for the right paddle, so let's hope. Okay, coming. Yes, we hit the paddle here. And we're going to hit it again. Okay? And again, this approach is much better for so many reasons. First, it's super easy to read as a human, and therefore for complex programs, it's much easier to understand. Then, as well, all the behavior and all the checks that need to happen are inside of the paddle. So everything is encapsulated much better, okay? And finally, here, instead of just printing the message, I can also say, take the paddle, take the ball, take the velocity x of the ball, and whatever it was, just make it negative. And now if I do left paddle, check collision B, okay, all of a sudden, I got my video game, I got this paddle working, and I got this auto paddle working. Great. And I got this one working. And it's, oh my God, we're almost there. Right? Here. How is this sounding? Hmm? Make sense? Did you understand why on this method I am passing as an argument, as information, I'm passing another ball object, and how I'm using one to read from the other? This is literally the way you make different agents and different elements in a program talk to each other, by passing them as information to one another from whichever the main program or the higher structure in the program is. Okay? So we have the main program has the paddles and has the balls. So it's the main program who's telling the right paddle to check if it's colliding with the ball. And the same for the left paddle. And then the paddles and the balls figure out what to do, how to check that, and what to do in that case.
Paddle, I have the collision working with the radius. The left paddle, it doesn't work with radius, it goes to the center point.
We're going to fix that. We're going to fix that because we are very clean and very high-level computational designers. So the way we have it working right now is we're bouncing off the center of the ball. And that's not cool. That's not great, right? Okay, so how can we fix that? How can we fix that? How can we... How can we, if we have a rectangle here, and the ball is coming this way, and the ball is coming this way, right now we know how to bounce from the center. But how do we bounce from the edge of the circle? Any guesses? It's much simpler than that. Remember the other day when we were bouncing the ball off the window, in the border of the window, and instead of bouncing from the center, we wanted to bounce off the border of the circle? It's very similar. How will we do it, Parker? If we're moving this way, right, the point that we want to check collision is not the center anymore. We want this point, which we know, because of the geometry of the circle, we know that this point is going to be the one that is going to be always at the front, right? And do we know, if we know the center and the radius, do we know the coordinates of this point? We do. It's just the x coordinate of the ball plus the radius. Right? So it turns out that if we're moving to the right, instead of checking the center, we can just check this one, and then we will do a perfect bounce off the border of the circle. Right? Okay, so let's do that. So, let's go back to the collision check. In the collision check, we're right now checking from the center. Okay? But we want to check from the right part. So we could do the following. We can say if ball x plus ball radius, and we can just copy paste that everywhere, except for the y, right? If we do that, then let's execute this code. And that's really slow. Okay, that was too much. Okay, let me just change the velocity of this thing here and make it 3 and 5 so that it always goes out to the right. Okay? Whatever. Okay, you see that? Is it bouncing correctly? Is it bouncing? Great. Yep. And how are you liking this? However, the other one. What about the other? What about the other one? Look at the left paddle. What's going to happen? Is this good? Nope. It is not good. Why is the left one not good? Because the way we've written this, we always check the right end of the x. No matter whether the ball is moving to the left or if the ball is moving to the right. So, how can we check this only if the ball is moving to the right? No, it doesn't. We can take a look at that later. What if, how can we say that we only want to perform this check if we are moving to the right, if the ball is moving to the right? Or in other ways, how do we know numerically that the ball is moving to the right or to the left? If s is increasing, and how do we know that x is increasing? What value is increasing x? If velocity in the x direction is positive, it means that the ball is moving to the right. So I can wrap this thing and say, if ball dot velocity x is greater than 0, then this is what you need to check. Otherwise, if this is not true, then you need to do a similar check, but instead of plus the radius, you need to do minus the radius, because now the point that you want to check, if you're going to the left, the point that you want to check now is this one. So you need to do x minus the radius, right? So if the velocity of the ball is positive, check blah, blah, blah plus the radius. Otherwise, check blah, blah, blah minus the radius. And if that, okay, that works, and that works, and that works, and that works. Guys, I think we got PONG. Finally, oh man. Okay? This can be written in a bit more clean way, okay? But I'm going to leave that as an exercise for you guys to look at in the sample folder, okay? But if this is easy to understand this way, it's fine. Yes, Mia. What is going on? I can take another look. I can take a closer look later, okay? I don't know right now what's going on. Okay, so collisions done. Parker. Yep. Let me see if I can reproduce that. You mean this thing, right? Okay. So how about this? Oops. Like when it glitches like right? When it goes like this? Yeah. What do you think the problem is there? there's a glitch. Parker is right. There's a glitch which is if the ball is moving this way and I'm moving down, if I just so happen to get inside of the ball as I'm moving down with the ball here, then the ball starts jittering inside and it doesn't escape. Why is that? That is because as I am moving down, this point becomes inside of the rectangle, right? Which means I trigger velocity negative x. But as I do that, that point, when it goes back 1 unit velocity x, it doesn't, because I captured it as I went down, is not anymore, because I go back 1 unit, it doesn't escape from the rectangle. And since it doesn't escape, then it keeps bouncing off and off, off and off. Okay? However, I think that should be fixed with this or something similar to this, because if you flip the velocity, then the point that you're checking is not this point anymore, but it's this point, and this point should be out. Is the ball really small and the paddle really big? In your case? Are you still checking the center? Okay, then we can take a look at that. Okay? Okay, so what's missing in the to-do list? What are we missing? The score. Okay, so that's going to be super easy. Okay? How can we do scoring? First thing, what will you use to keep keep track of the score? Salim? You would use a couple integers, a couple integer variables. For example, here I can define, in the global I can define integer left score, which is going to start at 0, and then I can type right score, which is also going to start at 0. Okay? Okay. And I'm just going to draw those scores on the screen somewhere here. For example, I'm going to say text left score is going to be on coordinates 30 and 30. And then text right score is going to be at coordinates with minus 30 and 30. Okay, I got 2 zeros here, which are indicating me the score of each player. All right? Now, I need to update those scores whenever any player scores a goal. How can I do that? Any ideas? With an if statement. That's a good one. Where should that if statement go? In the ball. Why in the ball? Exactly. Wherever I am doing the check to see if the ball is escaping on the right side or on the left side, that's probably where I want to implement my scoring system. Okay? And where is that happening? That's happening here, inside of the ball. This is the condition where I check if the ball went too far to one side or the other one. Okay? So, what can I do? I can say, well, now it probably makes sense to split this conditional, which is doing the same thing, whether if the ball is here or here. Perhaps I need to split now this in two, because now I need to tell one player or the other. I need to tell those two things apart, because I need to give the score to the right player or the left player, right? So here, I'm going to split this in two, and I'm going to say if x minus the radius is greater than width. So that is if the ball escapes on the right side. Okay? If the ball escapes on the right side, who gets the score? The left player, right? So what I can do here is I can say left score plus plus. And why does it make sense? Why can I write left score plus plus? I can also add the reset part. Okay? Why can I do left score plus plus? Because it turns out that the ball class also belongs to the global scope, because it's declared. You see that the ball class is declared here at the main global scope. And since it is in the main global scope, not only does it have access to its own properties, its own functions, but it also has access to any single variable that is global. And because left score and right score and blah, blah, blah were declared here as global, then the ball can access global variables and change them. Okay? This works otherwise if x minus the radius is less than 0, x plus the radius is less than 0, then write score plus plus and reset the ball. And as I do this, I'm going to score. There's going to be left score, and the player on the left keeps scoring over and over. Okay? Any questions? This was quite easy to do. Just a quick note here. Those orthodox, purist computer scientists will tell you, this that you just did here, it's okay, it does the trick, but it's not great. It's not great because it's considered not great practice to change variables in the global scope from inside a class. And why is that the case? Because it makes this class now, it makes it not reusable. If I were to copy paste all this code and put it in another program where the main global scope did not have a left score or a right score, then this class would crash because it would say like, oh, I don't know what left score and right score is. So good practice is usually when you encapsulate everything and the class only works with its own properties and its own behaviors, or information that has been given from the outside via these things, okay? From inside of a class, accessing and changing global variables is considered not great practice, but for the sake of this exercise, we're going to be okay, okay? The alternative would be to create a score class, have the score class have the left player score, the right player score, have like a way of rendering itself on the screen, and then passing a score object to this function, and then modifying the score from the object, okay? But otherwise, we're going to be here until Sunday, so we're going to stick with this one, okay? What about winning conditions? How do we make some player win? With an if statement. Where will you do that if statement? Here, in the main program. What will you check? Five. Whatever number. Then we do something. Yeah, I like that. So let's implement that. If left score is greater than 5, for example, then then clear the background with black, and then draw in the center of the screen left player 1. And that's going to be width divided by 2 and height divided by 2. Otherwise, if right score is greater than 5, then same thing, but with the right player. Okay, so I'm gonna lower this down to 2 for the sake of trying faster. Okay, but you see here I have my right player, the right player scores, the right player scores, and as the right player scores the next one, we get, we didn't, it has to be greater than 3, sorry. Right player 1, okay? Oh, hold on, what happened? It changed to left player 1. Oh, what's happening? Before we had here right player 1, but we were looking at the screen and all of a sudden it changed to left player 1. Yes, exactly. The only thing that we're doing here is on top of all the calculations and the ball bouncing and the paddles moving, whatever, we haven't really changed anything of that. What we're doing is we're making a check here, and if any of these checks is true, then we are overlaying on top of this, we are drawing on top of this a background and a message. But the thing keeps running in the background. So if it was the right player who won, then we're getting this message. But the thing still keeps shooting the ball, etc., and it keeps scoring. So if the left player gets more scores in the background, then at some point, it flips. Because we haven't stopped the game in the background. Okay? And you're worried that you're not taking it? That you're not getting it? Parker.
For some reason, once in a while, the collision will work, and sometimes it'll just bounce if it gets to the right or left side of the screen, no matter where the paddle is.
We'll take a look at that. Okay? Good. So what we need to do is we need to figure out a way to stop the game and either have the game running or have the game over screen running, but never everything at the same time. How do we keep track of something that can or cannot be happening? What is the best way? With a Boolean variable, okay? So we can create a Boolean variable here at the beginning and say, because I'm going to create a global because it's something that belongs to the whole game, like whether if the game is over or not. I'm going to call it game over, and I'm going to initialize it to false. Right? Because I want at the beginning to start playing the game. And then what I'm going to do here is in the draw loop, I'm going to have a really large if statement that says if game over is true, then print out the message. If game over is false, then just have the game running, have the ball bouncing, etc., etc. Okay? So, how do I do that? I'm going to go here and say if game over is true, I'm going to leave this empty. Otherwise, if it's not true, then I'm going to copy and paste everything that belongs to the game. I'm going to copy and paste it inside of the else. Okay? What I've done is I've created an if game over is true, then I will add here the code for the game over message. Otherwise, if it's false, then just background, render the ball, blah, 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 right paddle, etc., etc. Okay? And now, here, if the game over is true, then what I'm going to do is I'm going to paste this and say if left score was greater than blah, 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 then it's one player that won. Otherwise, it's the right player who won. Okay? Brooke. Did you get... Yeah, don't worry. Remember the block we had before? This, I have moved it inside of game over. Game over true. And everything else that we had, it's now on the else part of the game over equals true. So we've split the code that we had in the main draw in two parts. Everything that is gameplay is here. And just the game over message is in the first part. Of draw, but inside of if game over equals true.
For some reason, it doesn't go to the winning screen whenever it happens.
What do you think the reason is?
I really don't know.
Okay, let's track down the problem. If it never runs this code, then the reason is because game over is never true, right? And why is game over never true? Where are you changing it in your code to true? Nowhere. That's what's missing in the piece of in this puzzle. Now that we have this new condition, somewhere in the code we need to check if the scores are right, and if they are, then we need to change game over from true to false. Does that make sense? Okay, where will we do that? Wait, sorry, can you say that again? This is... No, we cannot do this here. Because remember, this never executes until this is true. So we can never change it to true from here, this part, which... You see? We need to do that somewhere here, where the main code for the main game is running. In the code that runs the game, here, we can say, if left score is greater than 3, or if right score is greater than 3, if any of these two is true, then game over is going to be true. And as we run this code now, we got the right player, 1, 2, 3, and the fourth one, and left player 1. And now I can tell you, you can trust me on this one, the game is not running anymore. Okay? Well, what is running now is just the message part. This part here, that is drawing the message for the left player or the right player. No? Parker? This text is not very centered. I'm going to add in my setup, I'm going to add text align center to make sure that all the text is always at the center of the screen, at the center of the coordinates that I specify. Okay? And I can go back down here. Okay? So this idea of keeping track of whether if things are in different states with Boolean variables is a super, super popular technique. Okay? And last but not least, it would be a really crappy experience if I would ask the players now to restart the game by closing processing, having to press run again, and going for a new one, right? So we probably want to do that from inside of processing. Sorry, from inside of the game, right? So we can probably implement something where we prompt the user, press the R key if you want to restart the game and start from scratch again, right? How can we do that? Very easy. First, let's implement the key recognition. As opposed to here, which is motion that we want to track continuously, and because we want to track it continuously, if the user is pressing, we want to move things around. That's why we check this with a variable inside of draw. Instead of that, what we want to for the reset is just one trigger. We want the user to press and the action to happen only once. That's why the key recognition in this case, we're not going to do it in the main draw code. We're going to do it in a dedicated key press function. Yes? But is the code running or is just the collision that? Okay. Did you save your states? Okay, go back to a previous version and see if you can regenerate that. Otherwise, we can take a look at that later. Okay. Okay. So here in key press, I'm going to implement the behavior that if the user presses the R key, then I am going to restart the game. Okay? Something that I would like to do, just for the sake of sanity, is, well, if let's just go for this. If I want to restart the game, I can just say, well, game over is going to be equal to true. Sorry, false. Right? One way to do this is to say, well, if it's the game over Boolean variable that keeps track of blah, blah, I can just reset this back to false and things should work, right? I'm going to lower this a little bit. Okay, so it's at 2 goals, it's going to score. Okay, great. Left player 1. So let me press R and let's see what happens. Can you guys look at the screen? I'm going to press R and up. And I'm pressing a lot, but it's not really working. Why is it not working? It's not working because it's Saturday, 5 p.m. Oh my God, of course it's not working. But aside from that, computers have no criteria for weekdays. What do you guys think the problem is? Turns out that changing the variable to game over to false is not enough. Because look at what happens. I change this back to false. Then, which means that I go back again to the main draw. This was false. So I'm going here. I'm drawing all of this. I'm moving the ball a tiny bit. I'm checking the collisions. I'm drawing that text. And then, when I hit this part again, because the scores are still 2-0, for example, this triggers again. And therefore, I switch over immediately to game over again. And that's why when I press R, I see a flash of one frame, which is all of this stuff that got drawn. But then I switch over to game over immediately because I have not reset the scores and made them back to 0 again. So, what do I need to do? I need to go here and say, let score equals 0, right score equals 0, and let's see if it works now. Left player 1, I'm going to press restart, and now the scores are 0, so I got my game running. Okay? left player 1. But hold on. Look at what's going to happen. I'm going to restart again. And as I restart, my paddles are still where they are. Because just like with the scores, I haven't changed them since the last game over. So if I were to develop this much cleaner, I would also want to implement something here where I move all the paddles back to the center. Or I may want to implement a behavior in the paddles such something as reset, right? And then I can call the reset method of those paddles. Or I can just take all of this and the paddles and everything and create a new function called reset game that whenever I call it, the function takes care of doing everything that needs to get done to make the circle, to make the game restart again. Like clearing the paddles, clearing the score, centering the paddles, and moving the ball to the center of the screen. Okay. Jessica, what happened? You didn't look like, you looked like something really big happened. Okay. Questions? We're done. Any questions? Any remarks? Any things you would have done differently? Anything you would have implemented and you don't know how you would have done it? Sorry? That's a really good idea. You can, if a player scores a goal, maybe you can reduce that player's paddle size to give the other one, the player that is losing, to give the losing player a bit more of advantage. That's a pretty good gameplay idea. Another one, you can speed the ball up. Right now it's pretty lame and it's boring. But every time the ball hits one of the paddles, you could increase the velocity X of the ball a tiny bit. So that the more you're bouncing off, at some point it gets like super fast and almost impossible, right? That would also make the game more exciting. Okay? You can, and this is always a nice idea, you can always, spice things up and give it like a nicer look. Something that I've done, for example, if you go to the samples in the files, you will see that if you open the file, I have tried to be very programmatic. So I have declared a lot of things at the beginning of my code, the width, the height, the margin, the color, etc. of everything, so that whenever I deliver a particular game, I can just tweak the numbers and then it can do the whole thing. I have also implemented score via a class. So there's a class called scoreboard that takes care of keeping track of the goals, keeping track of the scores, rendering on the screen, etc. And the game looks something like this. I loaded this nice 8-bit font here to make it look like Atari old school games. You have the file on the system if you want to use it. And something that I did, this game works good with two players working at the same time. The trick here to make multi-key is that because processing cannot read how many keys are being pressed at the same time, the trick to make that happen is to keep Boolean variables with trues and false for each one of the keys that you want to read. And then the trick is, instead of now managing those keys in the main loop, what you do is you have a key press function so that whenever any user presses any key, you set the variable for that key, you set it as true. So that if I press 1, 2, 3, and I'm pressing at the same time, I have 3 variables that say true as being pressed. And whenever any key is released, I go to the variable that keeps track of that, and I set it back to false. So that I can be pressing keys and releasing keys, And I have a set of Boolean variables that tell me true or false, depending on whether those keys are on or off. And then, in the main program, I can make decisions. If this is moving up, then move the paddle. Otherwise, move the paddle, blah, 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 based off those Boolean variables. Okay? Okay. Okay, real quick.